Is it possible to know things about which we can have no experience, such as infinity? To explore whether it is possible to know things about which we can have no direct experience, such as infinity, we can analyze this question through the lens of theory of knowledge, TOK, concepts, particularly knowledge and language in areas of knowledge, with a focus on mathematics. Knowledge and language. Language plays a central role in shaping and expressing our understanding of abstract concepts like infinity. TOK. The relationship between knowledge and language raises questions about how effectively language can convey complex ideas, especially those beyond our direct experience. The concept of infinity is a prime example. While we cannot directly experience infinity, we use language to describe, theorize, and communicate about it. The mathematical symbol for infinity symbol, is a linguistic tool that allows us to discuss the idea of something without limits. However, language can both clarify and obscure our understanding. For example, the term infinity may be used in different contexts, such as in mathematics, philosophy, or everyday speech, each with subtly different meanings. This linguistic flexibility can lead to a deeper understanding but can also create confusion or misinterpretation. Furthermore, language influences how we conceptualize infinity. In some cultures, the concept of infinity may be closely tied to spiritual or philosophical beliefs, affecting how it is understood and discussed. In mathematics, however, language is used with precision to define and explore infinity in a more formalized way. Thus, language is both a bridge and a barrier to knowing things like infinity, highlighting the importance of careful and context-aware communication in the pursuit of knowledge. Area of knowledge. Mathematics. Mathematics provides a unique framework for exploring concepts that we cannot experience directly, such as infinity. TOK. The area of knowledge of mathematics is often seen as a domain where abstract reasoning allows us to know things that are not grounded in physical experience. Infinity in mathematics is treated as a well-defined concept with specific properties and applications. For example, in calculus, infinity is used to describe limits and behaviors of functions as they grow without bound. In set theory, infinity comes into play when discussing infinite sets like the set of natural numbers. Mathematicians have developed rigorous ways to work with infinity, such as distinguishing between different sizes of infinity, e.g., countable versus uncountable infinities. Despite our lack of direct experience with infinity, the logical structures of mathematics provide a way to know and manipulate the concept. This suggests that knowledge in mathematics is not always tied to empirical experience, but can be derived from the internal consistency and coherence of abstract systems. However, this also raises questions about the nature of mathematical knowledge. Is it truly knowledge, if it is not based on experience, or is it a different kind of knowledge that relies on reason and logic? Critical thinking. The question of whether we can know things without experience, such as infinity, challenges us to consider the different ways in which knowledge is constructed and validated. In mathematics, knowledge about infinity is established through logical reasoning and symbolic representation, rather than through direct experience. This suggests that certain types of knowledge, particularly abstract or theoretical knowledge, can exist independently of experience. However, this also leads to critical questions. How do we know that our mathematical understanding of infinity corresponds to any real concept, given that it is entirely abstract? Is mathematical knowledge purely a human construct, or does it reflect some deeper truth about the universe? The fact that we can work with infinity so effectively in mathematics, despite its lack of experiential basis, suggests that human cognition and language are capable of grasping concepts beyond our direct experience. Yet, this also implies that our knowledge of infinity is contingent on the frameworks and systems we have developed, rather than on any objective experience. My stance. I believe that it is possible to know things about which we can have no direct experience, such as infinity, particularly within the realm of mathematics. This knowledge, however, is of a different kind than knowledge derived from empirical experience. It is rooted in abstract reasoning, logical consistency, and linguistic representation. While this form of knowledge may not correspond to a tangible experience, it is nonetheless meaningful and valuable within the contexts that give rise to it. This distinction between types of knowledge, experiential versus abstract, highlights the diversity and richness of human understanding, and the unique role that areas like mathematics play in expanding the boundaries of what we can know.